This lecture. Okay.
Yeah, yo, you're on TV.
Okay. Yeah. You're on film.
Girls on. I'm on. Yeah, TV. What is this city?
Girls on film.
You bitch, you don't take
Okay.
your pants off.
I think it's illegal now.
All right. So what we're going to look at today are problems involving E. Okay. And then how they work. So just like we did yesterday, we'll look at derivative problems and we'll look at integral problems. Okay. And we're going to start off with derivative problems. And just like yesterday, I'm going to do the first one, and then I'm going to start calling on volunteers. Okay. As a reminder, though, okay, to remind you how the derivative, integrals and derivatives of E works. Okay. The derivative with respect to x of e to the f of x can be written as e to the f of x times f prime of x. Okay? Likewise, the integral of e to the x is going to be e to the x plus c. Okay? And so if you're doing integration, by the way, how do you think it's going to work? Ultimately, if that's not an x up there, what's it going to turn into eventually? Not natural log, but a, what type of rule?
Oh, chain rule.
Chain rule or substitution for integrals. Okay? But those are the two big reminders for the homework today. Because I don't think there's any homework problems involving bases other than E, but we can look at those. Okay? Alright, so keeping that in mind, let's look at our first example. Our first one is going to be, this is 39 from the homework. F of x is equal to e to the 2x, and we want
On the night of the national championship.
f prime of x. What's that going to be? Anybody? How would I go about doing so?
That is 1 over 2x times 2.
You are thinking of natural log, and this is e. Okay?
Be e to the 2x. Do the homework.
Be e to the 2x
Times 2.
times 2. Good. So e to the 2x times 2. Okay, is what it comes out to be. Okay?
Isn't that what?
Again, you're just following the same, okay, the derivative rule, okay, for e, okay, is that the e part always repeats. Okay, and then you're multiplied by whatever the derivative of the e part, of the exponent. So notice, these always repeat. Okay? They always repeat when you're doing a derivative. They also always repeat if you're doing an integral. Okay? And it's just the nature of how E works. Okay? Remember, E represents the, is Euler's number, it's 2.7 and change. What this is basically saying, okay, or what you're doing with the derivative of e to the x, is if I have a function, if I have the function e to the x, let's say I evaluate it at 2, so e to the second, if I ask you what's the slope of e to the x at 2, the answer is e at 2. Okay, so it's a curve whose slope is its own. It's a function whose slope is the same function, basically. Okay, and that was bound to happen if you think about it. There's lots of different functions out there. There had to be one where, you know, if I look at the change in x at any particular point, it'd be the same as the original function. That just happens with e. Okay. But that's how this works, okay? Any questions? All right, let's get some volunteers. I want to see someone do 41. Come on up. We're doing the derivative of e to the square root of x. Okay? Any takers? All right, Darby, come on up.
Darby Hennigan, back again, looking for some fresh women.
Well, what?
Yeah.
What's your name?
Have a coffee.
You see the 60 minutes? I can't beat Greg.
Oh, hell. No, I told Teddy the same.
60 minutes on what?
Hamilton, reply.
Oh, what about it? They did a 60 minutes on.
It's phenomenal.
Did you see it, Darby?
I listened to the soundtrack, my brother.
Darbius Hennigan, the Roman gentleman.
DJ Khaled drink. Why does he own so many people?
How do you consider yourself a coyote? So what you're telling me is I gotta dig deep?
Yeah, dude.
You've done some meditation.
Of course I have.
Like,
Why would
you
I?
just sit there and go, oh mom, or you mean like sit there in bed at night and go,
No, I mean
"That's
like
my spirit."
actual sit down and meditate. Now, you don't necessarily do just meditate. Some people
Wait,
do.
so how did the
Where were you and what was the instance? Were you in your living room and you're just like, meditation?
I purposely went out and meditated to
celebrate success?
whole inner eye thing.
Okay, but
See,
how did
just
you
meditate.
how did you get
Uh,
into
can-
part of
can-
experience?
Huh?
Like how did you
I don't know. Like, if I'm going to like equate myself with any sort of animal, I mean, it's not like I was meditating and then you know a coyote came to me, you know, or something like that.
Oh, that's right.
Basically, like the idea of like a scruffy wild dog, okay,
I can see that.
sort of just I guess appeals to my psyche. Somebody who's you know,
Free.
you know, they kind of follow their own path, they do their own thing, they're a survivor, you know, and when you think about it too, it's like coyotes will eat anything. I pretty much will eat anything. You know, coyotes can be opportunistic. I'm very opportunistic.
I feel like I'd be a walrus.
Those sorts of things. I mean, so you know, equate that. Yes, Darby, you did this perfectly. Everyone got that? Okay.
Let's go,
That's exactly what you need to do.
They go
Now,
Darbs.
What? Good.
the only thing I would say,
Wow.
and this isn't any, this actually isn't anything serious. I wrote, take the derivative of this, you didn't need to write f prime of x equals, because you could have just, you could leave that off. That's not anything though, like if you had done that on the AP or something like that,
Like 3 points off.
you're fine. No, they're not even gonna blink an eye at that, they're just like, alright.
Wait, is that 1/2 x to the negative 1/2?
Yes. So it's e to the root x times 1/2 x to negative 1/2.
Yeah.
Because remember, the square root of x can be written as x to the 1/2. Okay? And that's the relationship between those two. Okay? But perfect. Again, note that e always repeats. Okay? Always does. Let's see another one. Okay? 43. Volunteer.
Jeff.
E x to the negative 4. Oh, this one's
Bittner.
I got it. What is it?
Bittner's never volunteered for
No,
anything.
never seen it.
Bittner
That's-
has literally never been up here.
Go for it.
Sam, why you done
No, you weren't.
So it's.
Sam, give Bittner a chance.
You want it?
Yes, put
Wow.
the marker
I
down.
got it.
I got it. I got it.
No, Clayborn.
I got it.
No.
The x minus 4. Okay. Times.
E always
What's the
repeats.
time? Times 1.
So this one literally just came out again to be e to the x minus 4. Its derivative is literally itself. Again. Okay? It's just again, it's how e behaves. We saw on Saturday how we could find this derivative. Okay? It comes from manipulations of the natural logs and stuff. But if you actually sat down, okay, everybody, and did this out using limit definition of derivatives, this would be the answer. This is what you would end up getting. Okay? Every single time. It's just how e to the x works. Okay? It's very self-referential. All right. Volunteer for 45. 45 is the first one. We're going to see, okay guys, where things get a little bit trickier. We're going to do derivative of e to the x natural log of x. Okay?
Wait.
Wasn't E times natural log 1?
Natural log of e is 1. Okay? This is, but you're on the right track. Think about this. What's going on here? You said it has e to the x times natural log of x, right?
Yeah.
So it's a what? It's a product rule. That's all this is. So you just do the product rule to it. Now that you know that this is a product rule, any takers? Should be super easy.
Yeah, I got it.
Alright, Bo.
We got Bo. You sure, Bo?
Get after it.
I can probably do it.
Hey, well,
Bo Jackson.
what's
that 30 on 30 called?
It's bow time.
No, no, no.
Photos. Photos.
Bodo's. Bodo's Bagels.
What's the 30 on 30 about Bo Jackson?
Charlottesville, Virginia.
You don't know about
That's
You guys don't know Bo?
That's bagels.
He was an athlete.
Are you
Bo Jackson was.
Oh my god.
Because I am
You did the colors.
Perfect.
Represent.
Done. That's exactly it.
I know
Okay.
the photos when I have the munchies.
Okay. Derivative of the first thing, keeping the second thing the same, which is exactly that. Derivative of e to the x is e to the x. Okay.
I don't chase.
Then plus derivative of the second thing, keeping the first thing the same. Okay. And so that's the answer you come out with. That's perfect. Okay. One variation, I saw someone do this yesterday, and feel free to do this as well. What they did when they did the derivative of the first one, they did e to the x times 1. Okay. Natural log of x. Now you don't have to do that. Okay, so
that's what the, yeah.
but the reason why that was useful and kind of nice, and I was like, yeah, keep doing it that way, that was cool, is because it lets you know, hey, I've done the derivative of the first one.
That's true.
Because you can see it there.
Yeah, I was
Okay.
confused a second ago.
I got you.
Okay, but now you see it, right?
You just. I don't like
Okay.
The
And you're good to go.
Weird.
Okay.
Wynn's derivative is 1 over x.
Yep. That's the natural log.
I just want to make sure that wasn't there. Sorry, I don't
Oh,
know.
all
I
right.
like it.
Okay.
Who's changing color?
We're interested.
Let's see. 47 is going to work exactly the same way this one did. Let's look at 49. Okay. 49, the last one of this problem set I assigned. Okay.
Actually, I don't.
We've got g of t is equal to e to the negative t plus e of t. What is it, squared? I think it's squared.
Stop touching.
Cubed.
Stop touching.
Guys,
It's hard to focus.
Guys are
what?
children.
Is messing with his foot?
Whoa.
Why are you looking at this with me? Why look? I mean, just pay attention to me.
Why are you looking at his foot?
Please stop.
You should see it, it's great.
Why are you looking at it?
Why does he have like a bunion or something on his
Dude, it's worse than me. He's like no time now.
Because I had surgery on it.
I'm just saying, man.
Please stop talking.
Alright.
Stop touching.
See, the back row can have fun and focus. Continue, please.
How would one like this one, if I'm looking for its derivative, okay?
like a chain rule?
It is exactly like a chain rule. Good. Okay? So what's the chain rule say I do? Someone take it.
So you're gonna go.
Come on up.
Let's do this.
Exactly. Let's do this.
Legend.
Remember, I know how to do all these.
Oh, Graham, you chose a bad one.
Yeah, this was nice and easy.
Yes.
Whoa.
Yeah, everybody says I always write.
I'm so mad.
Multiply, right?
Okay. Up, where you leaving off?
Squares.
Chill out. That's in the thing.
There you go. Now multiply.
At least he's like, not a.
Alright, what's the derivative of e to negative t?
Yeah, Graham. -1.
Oh yeah.
She's eating the negative
Yeah.
I'm trying to think.
Okay, well what's the rule? What's the rule of e? What always happens?
1 over.
Stays the same.
No, doesn't go 1 over. You're thinking natural log.
Natural.
It's e to the negative
Stays the same.
times.
Stays the same, so it's e to the negative t.
Wait, what? How do you draw an E like that?
Now times,
That's what, I
What's
was showing my
the
A's
derivative
back.
of
I was showing my
negative
O's from
What?
top to it's weird. What?
what's negative t? A
I
derivative
draw
of
my
negative
O's
t.
from the
It's
top.
It's
Negative
negative 1.
negative what?
I mean, he draws his
Graham.
O's from the top or the
Plus,
Bottom.
bottom? Whoa.
okay,
Where do you draw your S's from?
and the derivative of t is 1, so you only need to do this. You're done, you're finished.
about L?
Parentheses and you're good. There you have it, okay? Again,
Who does the O from the
this
bottom?
is just a product,
Wait, I
this is
do
just
it
a,
from
sorry, a
top.
chain rule, okay? And it works exactly the same, every chain rule works, okay? Just when you hit the derivative on the inside, the special rules for e apply, okay? And again, so the other one that became weird was e to the negative t, simply because of that minus sign, okay? But it came out normal. Any questions on how any of this worked? Okay? It's fairly straightforward, right? It's not too terribly difficult. Alright, good. Now, the second half of what we did last night, or should have done last night,
Wait,
Okay.
no.
are integration rules. Okay? So, okay, guys, stop talking about the foot. Okay?
I'm worried about him.
Wait, can you go back to that last one
Here,
for
just
like
put it on video real quick.
5 more seconds?
No, don't put your gross
Flash
foot on video.
Just flash the foot up, let everyone know what we're
I
talking
don't
about.
want to have to edit these videos.
The people
after
are
I'm
probably
done.
confused as to what we're talking about.
The thing is, the people who would be you watching this video later, and since you're sitting in my class, I mean, yes, these are open to the
Wait,
public.
does the sound come on the video?
Oh yeah, absolutely.
So we're getting all this?
Yes. Recorded on
Both
YouTube for
Stop taking
posterity's
your
sake.
pants off.
Yeah, he's not. Yes. Okay.
Hey, Mom.
But the audience is you. The audience is Woodbury boys.
What if
You're in my classes.
What happens if Keating decides to hop on and see
Well, then he sees what one of my classes is like on any given day. I really don't care.
That's why. See, that's why.
He already knows what my classes are like.
You're a coyote. Dude, coyotes hunt in packs.
No, they don't. They hunt
No,
solo.
you don't.
Yeah,
Coyotes
wait,
are-
have you ever seen Bobby?
What?
Bro.
Yeah, coyotes
So
don't.
wolf.
No, wolves hunt packs.
Coyotes don't hunt
Rarely
packs.
get together in groups.
Really?
This is no.
Well, I'm a lone wolf.
Okay.
It's even more special.
Got this down?
because I went
Hey.
against my nature.
Hey, you got this down now? Can I go?
Yeah, I got it.
Okay.
I got
Thank you. All right. Next up. Okay, everybody, focus. Integration. Okay, we're going to do the same thing. We're going to look at E with integrals instead to make sure we got these down, okay? Our first one, again, I'm going to do the first one. Our first one is e to the 5x times 5 dx, okay? And we want to know what this antiderivative is, okay? Now, most of you could probably go ahead and figure out what it should be. What's it going to be?
Five times E.
5 times e.
Oh, E to the 5x times 5?
Okay, so you're thinking e to the 5x times 5. Remember though, these are antiderivatives. Okay?
Oh.
So what happened before? When I did a derivative, if I did derivative, for example, of e to the 5x, it would come out to be e to the 5x times 5, right? So I'm reversing that around, so what should this just come out to be?
E to 5x.
5x.
Plus C.
E to the 5x plus c, okay? It's pretty easy for one like this one. Oh, it's pretty easy for one like this one to see why that's the case, okay? When they get more complex, it becomes a lot harder. What's really going on here, what you're actually supposed to do with this, okay? Now, with this one, if you did it this way mentally, perfectly fine, okay? That's perfectly good. In fact, who was it? I've seen other people do other variations on these, so that way they just learn it as a rule and just quickly do it instead of having to do it the proper way. But technically what you're supposed to do with this thing is a U substitution, okay? Remember, derivatives of E are all technically chain rules, and the reverse of the chain rule is a substitution. So, if I were to follow that rule here, if I was to do this by U substitution, the part with the x becomes U, so that would be 5x. So U is equal to 5x. Then du would be 5 dx. So I make my substitutions because I've got everything already. I would just have the integral of e to the u du, which comes out to be e to the u plus c, which if I wanted to put back in 5x for, I most certainly can. Okay? So that's actually what we did, okay, when we just reversed things very quickly. We're doing that u substitution. Okay, but if you can recognize it off the bat, go for it. Okay. Now, with that in mind, okay, could I get a volunteer up here to do the next one? The integral of e to the 2x minus 1 dx. Okay. Now that you know what it is. Okay. Who wants to try it out?
Should I go for it again?
No, you've already done one. You're
Bittner's
good.
never done one ever.
Bittner's never gone out.
He's literally never been up on the board.
You don't like to single anybody out.
I don't like this thing.
Bittner said he'll do it. He said he'll do it.
All right, come on up. Thank you, Brad.
I have good picks.
Bittner.
I really do.
Bittner.
No, I usually don't have to pick on people because you people usually pick on each other.
It's not that nerve-wracking, Bittner, don't worry.
We're just trying to help
The
educate
only
you,
part that's scary
Bittner.
was when you don't know the
Your
answer.
daddy is proud of you.
And I can tell you right
And,
now.
Daddy, how you working for him now?
okay, you are almost correct. You're going to be missing out. You're missing one little thing here. Okay. This is 2x.
Oh, yeah.
What do you think I need to add?
Uh-oh.
There need to be a 2, but then what has to be on the outside? A 1/2. So what do I need over there? The 1/2. There you go. Perfect. Okay. And that's spot on, okay? And so he was able to recognize, for the most part, hey, integrals of e, they just repeat the e part again. But then I might have to make a small minute adjustment because it's not x, okay? In this case, you add a 1/2.
He inserted that
In there
two
is
in too, right?
low-key the
Uh-huh.
smartest
He
guy.
put that two in?
2 and a 1/2, yeah. When he saw it, when I went over it a second time. Guys, again, what's going on there? How it actually works is we're doing a u substitution, okay? U would be what?
2x minus 1.
2x minus 1 du 2 dx. And that's why, hey, we had to have a 2 in there, which means we had to put a 1/2 on the outside. Okay? U substitution, yeah.
Oh, did he add the 2?
He added the 2, yes. He added these things right there.
So where do you, so if you were to do it the U and D way, how would you do that?
Okay,
That's right.
basically, the proper way to do it with the u substitution, okay, is you choose the thing with x to be u.
Okay.
That's why it's 2x minus 1.
Yeah.
Okay. The derivative of u would become 2 dx. I don't have a 2 in there. So I put a 2 in there, but I also have to put the 1/2 on the outside. Okay? So basically, I go for my original one, and I stick in the 2 and the 1/2.
That 2 basically comes in because your du is 2 dx.
Exactly.
Okay. Alright.
And so that's how I got my,
So basically what you're teaching us is how to skip a step.
yeah.
Yeah.
Okay? Or how you could recognize it for certain ones you can skip a step. Okay? And so there's my du, but to account for that, I added the 1/2 on there. Okay?
I'm still impressed to recognize how to you make 2x minus 1. Are you always going to do that for the substitution?
For the most part. Okay? Everybody, ideally speaking, okay, remember, the rule behind substitution is you usually pick the thing with the highest power x, or the thing in parentheses, or in most cases both,
But it's the X.
to be your thing. But still the thing with the highest powered x, right?
Yeah.
So that's what you should be. Okay? Remember, always follow that rule and you shouldn't go astray. With e to the x problems, if you just have a single e to the x in the problem, chances are the exponent is what you're picking to be u. Okay? Now, we have examples, in fact we'll do examples down the list, where we pick something else to be u, but you get the general idea, okay? So this thing becomes 1/2 up there. 1/2 e to the u plus c, which we substitute back in, we go right back in. Okay? Any questions? Alright. Let's have